All right, these are the FRQs from today, the Saturday before the big test. I'm so proud of all of you that showed up today. I know some of you couldn't stay later, and this went way longer than I thought it would. So here is your video, and even those of you that did stay, we kind of jumped around. So this will kind of clear up everything, hopefully. And you can always email me or text me through Remind if you have questions about anything as you're wrapping up. All right, so, oops, here we go. Now, you will have to bear with me because I am doing this on my computer. I can't do this on my iPad, which I would have much better handwriting and be easier to point with because I can't get the calculator on there. So this is the best way I can figure it out. So my handwriting will be worse than ever, but that's okay. All right, FRQ 1. The figure shows the graph of the decreasing function. All right, so words like this in here, decreasing function. Now we can see that it's decreasing, but sometimes the fact that they tell us that is important. So we do want to pay attention to words like that. Decreasing function of f on its domain of all real numbers where x is not equal to 1, okay, because we can see x can't equal 1 because we have a vertical asymptote there. Then they give me these 2 points. The fact that they're actually stating the points is probably important to me, so I'm also going to put them on my graph. I'm going to have even harder time actually aiming with my stylus. Well, we're just going to pretend like that's, oh, you know what? I just realized I'm not on my stupid board, so I can actually make a point like a normal person. So let me just do that. And I can put a point right there. I say like a normal person, but it's going to look like a mess because of the stylus, whatever. All right, so then 3, 2, there's my point. Maybe I can't make a point. All right, there you go. There are my lovely points. I left my good stylus at school, so I'm using a cruddy one, and that's one reason why I can't do this stuff right either. So this is the graph of f. Okay, we have f and g, and they're going to alternate by asking us things about f and g. So I want to make sure I'm paying attention to the fact that this is f, and this is g. So I don't look at the wrong one at some point and use the wrong thing, because I do think that that happened to some of you on some of the mocks that we did. All right, so remember on the real thing, you also have way more room to work. I was just trying to condense this on the pages, so it's a little crammed, but it'll be fine. All right, so I have the function h, and they define h for me. And so h of x is equal to, so that's g of f of x, and I want h of 3. So actually, let me do this. H of 3 equals g of f of 3. All right, so f of 3, f is the graph, so I can get f of 3 from my graph. That's this right here. That is 2, so now this is really what I want, g of 2. This is where the calculator comes in, because remember, FRQ 1 and 2 are both calculator functions, or calculator questions. Now, I'm at the beginning of this question, and I need to use g of x. I could put it in the calculator screen, but I think, if I want to use it over and over again, it's really better if I put it in the graph screen. So I'm going to go on. I want new, no, and I'm going to add a graph. And then I'm going to put this in. I have 2 plus 3 natural log of x. There we go. Then always double check that what you put in there is actually what you meant to put in there, and I'm going to hit enter. Right now, I don't really care if I can see the graph or not. I can, that's great. But what I want is g of 2. Now I'm going to make myself a note here that in g of x, I put in f1 in my calculator. So since I want g of 2, I can add a calculator. And then I can't say g of 2 because it's not called g, but I can type in f1 of 2. And that's what I want. I hit enter. And then my answer overall is 4.079. Okay, so that's part 1. That is worth 1 point. Then I want to find all the zeros, or all the real zeros of f. The zeros are the x-intercepts, and it's anywhere it crosses the x-axis. I think that's why they gave me this point. Now, some of you answered this question correctly, but in a form that maybe is questionable. I don't know. Like if you put it in an ordered pair, or you say, or if you say f of 0 is something, that's not correct. But using different forms like that, there's been discussions in these groups about whether or not that would be okay. I mean, as long as you say it correctly, in my opinion, I think they would give it to you. Like if you just gave me the ordered pair and gave me that, probably. But technically, this would be an x-intercept. These zeros are x values, so we should really just have x equals. And then we know that if that is our 0 right there, that's where we cross the x-axis, x equals -1, and that is like a crazy easy question, okay? So if you have, and you're going to be asked something like that, it might be from a graph, it could be from a table, but that's still something that hopefully you can get pretty easily, and that is worth 1 point. All right, so now I'm going to go to B. It says find all values of x as a decimal approximation for which g of x equals e. Well, g of x, remember, is in F1, and I want to know where it equals e. So if I'm going to set g of x equal to e, so that means, and I'm looking for an x value where that happens. If they give me the y value, y is what we put into the calculator. So I'm going to go back to my graph, hit tab. So remember, in F1, I already have g. In F2, I want to put e. So e to the x, 1. Do not use e from the keyboard. Do e to the x and do 1. The keyboard one, there's something up with it. I don't remember what it is, but I just put 11 by accident, so make sure you just put it to the first power, and I hit enter. Okay, so that's where they intersect right there, and it's not saying where do they intersect, it says where does, it just says what are the x values. And so then I want to know, like, maybe there's more than one place where they intersect, but if you know what your functions are, this is a natural log function, so it's only going to look like that. It's not going to come back down or anything, so I don't have to worry about it. If it was a sine function or a parabola where I knew it would come back down, I'd probably need to see more of the graph. But I just need to find that intersection. So I'm going to do menu. I'm going to analyze the graph. I'm going to find the intersection. I'm going to scroll over here. I just need to be on the left of that. Enter. There. And then remember, I want the values of x. So x equals 1.270. 1.271 would be acceptable as well if you round, but that's worth 1 point. So then we talk about end behavior, right? Determine the end behavior. Express your answer using the mathematical notation of a limit. Okay, so, and we're talking about g, not f, so I got to look at the right thing. So I'm going to say the limit as x approaches something of g of x equals something. Okay, so then I have to figure out what those somethings are. So when I have g, I'm not looking at this graph, I am looking at this graph. And remember, if you feel like you need to zoom out some so that you can have a better understanding, if you're not sure what you're looking at, I mean, natural log, maybe you know, but maybe it's something else that we're not sure of. We can just click zoom out, but you see where my magnifying glass is? I want the center really to be at 0, 0, so things don't get too crazy. And then you can zoom out a few times, and it definitely does just look like a natural log graph. So as x approaches, now it says end behavior as x increases without bound. So you want to be careful. It's not decreasing without bound. That would be something different. But increasing without bound, we are approaching infinity, g of x, and that's going to equal infinity. And I think what I wrote would get credit. I wish I could write it neater for you, but I do have a touchscreen computer, but it doesn't lay all the way down where I can, or it doesn't flip around, so the keyboard's in my way and I can't put my arm down. I'm sure there's a better way to do this, but I don't have time to figure it out, so y'all be fine. All right. Then it asks if f is invertible. Oh, wait, this was worth 1 point. This question has only two answers that would make sense. Yes, it is invertible. No, it is not invertible. So in this case, if you have no clue, then you say, I'm going to guess one, and I'm still going to answer this. I either say, yes, F is invertible, or F is not invertible. Here is F, because this is F. I don't care about G anymore. Is it invertible? Now, if it's invertible, that means I can not only take the inverse, but the inverse is a function. So I know this is a function because it passes the vertical line test. I know the inverse is a function because it passes the horizontal line test. Now, making those statements is not enough to explain it, but it's enough to make it make sense to you. So I can say here that F is invertible. All right. And then it says, give a reason for your answer based on the definition of a function and the graph. Okay, so I'm going to, because I have to write a lot here and it's going to look like a hot mess, so I think I can use a text box. Let me type this for y'all. There we go. Oh my goodness, that's too big. So let's see. That'll be good. Okay. Here's the problem with some of your explanations. Some of you said things like, for F to be a function, every input has exactly one output and every output has exactly one input. That is not a true statement. To be a function, every input has exactly one output, period. To be invertible, then every output also has exactly one input. So I understand that those words can get confusing and it's easy to say it backwards, and it's also easy to over explain, which I think is what was kind of happening with y'all. So I'm going to give you you got two answers here. Again, either it is or it isn't. Okay. So this is what I would say here. I would say F is invertible because for every input there is, I'm not much better at typing, exactly one output, and for every output there is, every output there is exactly one input. All right. So that says it all right there. Because some of you also, I think you were trying to explain that the inverse would be for every output there's exactly one input or something like that, but you weren't saying inverse. Y'all were using it a lot. And you got to remember to leave it out of your vocabulary. All right, so this works. Now, there was some question today about, well, isn't that first sentence just enough? So let's just take a little side trip here to talk about parabolas. If I have oh my goodness gracious. Every time. So let's just talk about parabolas. So if I have this parabola here, and this is at -2, and this is at 2, then this here and here, those are both at 4. Okay, so that's just like the parent function. So for the inputs, they have exactly one output, but this output of 4 doesn't have exactly one input. That's why a parabola fails the horizontal line test. So if your answer is yes, you can write this sentence. If your answer is no, then here's how you can change that. So if you can get this sentence in your brain, then I think you should be okay. Let's see. What I'm going to do here is I'm going to, if it will let me, copy this and then paste it. Yep. And I'll grab one of them and move it out of the way. Maybe. Everything hates me. Everything hates me. Okay, hold up. Oh, now it's frozen. That's about right. Okay, if I just get out and get back into it. All right, I'm going to pause this and then figure it out. Although apparently I've lost my pause button too, so there we go. Okay, so if, let's say the answer is not, then you can answer it like this. F is not, just thought I got it figured out. Joke's on me, isn't it? Holy crap. Not. What is wrong with this thing? I'm hitting space. This video's going to be 3 hours long. I don't want to type there. I want to type here. I'm going to try spacebar one more time. What is... I didn't hit anything. I swear. Okay. Then I'm going to make that. Maybe I shouldn't play around with it too much. Yeah, see, then it goes back down there. I don't know. All right, I'm going to pause again, and then I'm going to fix this, and then I'll come back, so I'm not wasting y'all's time. Okay, this is what I was trying to show you. If your answer is F is not invertible, this is all you have to change. You can say F is not invertible because for every input, there's exactly one output, and for every output, there is not exactly one input. That second part basically says that it fails the horizontal line test. You don't have to mention the vertical or the horizontal line test. These words explain what it is. But they've been very specific about the fact that you have to use words like this. I would use input and output because that's what is happening. And I think if we get these sentences down, then we'll be fine. And so you get a point for this. Oh my gosh. A point for this and a point for this. So there are your 6 points there, which hopefully you can get. Okay. So this one really overall wasn't too bad. I don't think it was too challenging. Now, FRQ2, it is a little bit more challenging. And I chose some that were more challenging purposefully so we could talk about some things. I mean, how difficult is it going to be on the actual exam? No idea. Because some of these have been fairly simple and some of them have been more complicated, and it really has more to do with the function that they give you and what you're expected to do with that. So I picked this one in particular because it has a piecewise function, and I know how much those freak y'all out. So I thought we should at least talk about them. All right, so overnight a large snowstorm passes through Plugtown. Snow began falling at 12 a.m. T equals 0. Okay, so two things here. First of all, if it began falling, that means there was no snow, okay, or that's the implication here, at T equals 0. So that means I have an ordered pair of 0, 0 in my function. Okay, and continued to fall until 6 a.m. T equals 6. Now, here's one thing I think that is nice that was done here, is sometimes they will tell you this, but then they won't give you the T's here, and you're expected to count the time, so don't mess up the time if you've got to do that. It continued to fall until 6 a.m. Once the snow stopped falling, Mr. Passwater began shoveling the snow off his driveway. By 9 a.m., T equals 9, only 25 cubic feet of snow remained on Mr. Passwater's driveway. The amount of snow on Mr. Passwater's driveway in cubic feet can be modeled by the continuous piecewise function. Okay, so they told me at 9 there was 25 cubic feet. So I've got that. I can write it. This is terrible. 25. Okay. And they gave me this 6, but I don't know what's supposed to go with 6. So let's go back and let's just talk about what it said and what we know here. So piecewise functions can look like a lot of things. So let's just go here for a second. I could have a piecewise function that looked like this, open circle, and then maybe closed circle. Oh, look, I'm having the same issue I have on my board. Pretend like that's a closed circle. It could look like that, and we could have a jump. It could look like this, and then we do something, we have an asymptote or whatever. It could look like this, and then we have a parabola or whatever. But this says that we have a continuous piecewise function. So I know that I have a linear part and then I have an exponential part. And so I'm thinking the exponential part, he's taking snow off, so it's probably a decreasing function. So if we have a linear and then it's going to be decreasing, like something like that, but it's continuous. But here, right here, that I can't make a decent point, is where they connect. So I need 6. If I substitute 6 in, technically I'm supposed to substitute it into the second one because that's where 6 is included. However, I can't because I'm going to need to find something for A and B, but it should be the same as whatever it is at the end of this one because they connect together. So I can just substitute 6 in there and I get 70 times 6, and that's 420. So that's 6, 420. That's how many cubic feet were there when the snow stopped falling. Okay. Now, I've seen other piecewise functions on these where this might just be a constant, so you don't have to substitute anything in. So that might not even be an issue. Okay, so just put that aside if figuring that part out was confusing, because that might not even be an issue. But we do not need to understand kind of what's happening with these piecewise functions, right? Okay, so it says S of t is the amount of snow in the driveway, blah, blah. Okay, use the given data to, all right, guys, we are going to write 2 equations. So we're going to have something equals A times B to some power, and something equals A times B to some power. Now, I messed this up today when I was doing it with y'all live and in person, and I accidentally used 0, 0, which I cannot do because 0 is here. 0, 0 is here. 6, 420 is really, it's in both, even though, because we can't include it in both, that's not legal. So I can use that, and then I'm gonna have to use the 925. So I've got 25, and then that would be to the 9th power, and then 420 equals A times B to the 6th power. Those are my 2 equations that I wrote. I just wrote them. That's it. I did no work. I did nothing else. I have 2 of them. The reason I need 2 of them here is because I have 2 unknowns. The reason we had 3 on another one is because there was 3 unknowns. So I don't have to use this 0, 0 here. But it is something that I know that I might need later. All right. On the second part, we have to find the values for A and B as decimal approximations. So here's where we're going to use our regression. Now, well, in my calculator, I have stuff for FRQ1. And you know what? Maybe I need to go back to FRQ1 and I don't want to have to retype stuff in. So I'm going to show you something that you wouldn't necessarily have to do. You could always go back and retype it in. But when I go to get a new one for FRQ2, I'm going to say 1 for new. And instead of saying no, I'm going to say yes. And then I'm going to title this FRQ1, because that's what it was that I did. And I'm going to hit save. Now I already have one with that name because I showed people today, or I've showed people before. So I'm going to just hit yes. I want to overwrite it. So now I'm where I would normally get a new one. I'll show you how to get to back to FRQ1 if we need it. All right, so I'm going to find the values for A and B. So that means I need to add lists in spreadsheets. I'm going to go up here and do X. And my X values that I'm going to use, I'm not using 0. I'm not using this one because that is in this part up here. But I am using 6 and 9. And then Y. And that would give me 420 and 25. Then menu. Well, okay, but see how I didn't hit enter? I got to hit enter, or I'm not going to enter, or at least arrow out of it. Menu, statistics, stat calculations, and this is exponential, so I can choose A. And do my thing. Y'all are good at this. Enter, and there we go. So I can say that A is equal to 1185.40.8. Now that's all I can see. And I know I'm supposed to do things to 3 decimal places. All right. So if I'm like, well, I think that's probably just all I can see. If I click on that number, then down here, I can see the actual full number, and it actually does just end in 0.8. If there was more decimal places, I could see them there. But sometimes it might get cut off like that, and there's really more there. Like, look, when I click on, oops. Well, I didn't want to actually change anything. When I click on that one, it shows me all the rest of the decimals. Not that I need them, but then B is equal to 0.390. Okay, it only asks for A and B. So just give them A and B. Don't write it in an equation. All right. You can, I mean, if you do and you do it correctly, great. If you do it and do it wrong, that's bad. So just give them A and B. That's all they want. All right. So then it says use the given data to find the average rate of change. Average rate of change just means slope. Average rate of change. I'm looking for the slope. We can do slope. Okay. Even if you couldn't do A, you can do B. Because if I want the average rate of change from 6 to 9, then that means I need S of 9 minus S of 6 over 9 minus 6. All right. Now, I'll say again, say it every time it happens. Do I have to write what I just wrote? No. Should you for yourself? Absolutely. Because there were a couple of you that got these in the wrong order, but 9 goes with 9, 6 goes with 6. All right, so then I know that S of 9 is 25 minus S of 6, which is 420, over 9 minus 6. This is a calculator question. Let the calculator do the work for you. So control, add a page. Nope, that's not what I wanted there. I guess I hit the wrong thing. Control doc, so add a page. I want to add a calculator. So I'm going to start with a fraction, and then I'm going to put 25 minus 420 over 9 minus 6. Boom. So I get negative 131.666, or 667. That's my answer. Now, the next one says to use the average rate of change that you found. So remember, even if you mess this up, but then you use it correctly here, you're good. So just keep going. Even if, okay, so let's say, this is how you'll have to learn how to play the game. Let's say that you didn't know you were supposed to find that number there, and you didn't know what was going on here. And then you get here and you're like, well, I have to know what S of 6 is. So make up a number, put an ordered pair somewhere and say that, oh, this is 6. And so, oh, then I'm going to use that number there. I mean, you got to have something to be able to use it. You won't get all the points, but you might get something else. All right, so we're going to estimate it. Now, you can estimate this by writing the equation of a line or by just using the slope, which, by the way, this came up today, so I want to just point this out. Point slope form, which you hate and you think is so complicated, check this out. You've known how to do slope forever, right? So y2 minus y1, those look like 4s, I'm sorry, over x2 minus x1 equals the slope, right? Well, if I multiply both sides by the denominator here, I get y2 minus y1 equals m times x2 minus x1. And guess what, ladies and gentlemen? That is your point slope form. It's really just the slope, okay? But I don't want you messing that up if it freaks you out at this point. So, oops, I do not want that. So instead, we can use this slope. Now, this is an ordered pair. This is an ordered pair. So you can pick one of them to leave. I usually just leave the first one. Just to me, it's a little bit easier. So just 25 minus something over 9 minus something is going to equal negative 131.666. Now, this is in the calculator. I'm not going to actually type that back in, but I wrote it down for myself. I want to estimate it at t equals 7. So this would be 7. This would be S of 7. I don't know. I mean, I could write S of 7 there, but I can also just call it Y for myself right now. Now I got to get Y by itself. So 9 minus 7 is 2. Or let's say that I'm not even sure what 9 minus 7 is, or I don't want to mess it up. I'm going to multiply this by this number, which is right there in my calculator, right? So if I just do times, it's going to take the last answer, and then I can put in parentheses 9 minus 7, so I don't mess anything up. Okay. So now I've got negative 263 something. So that means that 25 minus y equals negative 263 something. You wouldn't even necessarily have to write it down. I'm just putting that down because I'm not typing it back in. And that is a minus. I'm trying to get y by itself. So I'm going to subtract 25 from that. So I'm going to do minus 25. So I get that y, negative y, oh my God, my handwriting is getting worse, sorry. Negative y is equal to negative 288 something, something, something. So if negative y equals negative that, then y equals that. Well, that is, we are estimating there, we are estimating S of 7. So S of 7 is about 288 point, and I'm getting this from my calculator, 333. Again, if you want to write the equation and do that, totally fine. Alrighty, so now I want to consider the average rates of change of S from 9 to P weeks, where P is greater than 9. Are the average rates of change less than or greater than the average rates of change from T equals 6 to T equals 9 hours? Found in I. Explain your reasoning. All right, so what I would like to know now, well, first of all, we're talking about rate of change. So if I am talking about rate of change, I know that I need my fun chart. So here's my fun chart. Oh my gosh. I'm sorry. This stylus I'm using is the only one I could find quickly, and it's a piece of crap, so. All right. Here's maybe my fun chart if I can get it written. Rates. Okay. This is why I would never be able to actually make these videos for money, because people would just laugh. Okay. All right, so there's my fun chart. If I want to know if some of these are greater than or less than, I'd be looking at whether or not the rates of change are increasing or decreasing, which means I need to know if my function is concave up or concave down. So I need to look at my function. The 2 pages I have in my calculator right now, I have the graph page and I have the regression page. So I want to add, I'm sorry, I have the calculator and the regression. I'm going to add a graph. Add a graph. And remember, F1's already in there. So I just, oh, there it is with all its glory and all its digits. And then I just hit enter. And well, I didn't see anything. But, oof, go away. But remember, our numbers are kind of big, right? We went all the way up to 420. And so I think, and I started at 6 and we went to 9. This goes to 10. So maybe I go to 500 and I can see what it looks like. So menu for Windows settings, I'm going to change this to 500. Let's see what it looks like. Oh, that's what it looks like. And so I can only see part of it, but at the same time, I know that it is, sorry, my brain is not braining. I know that it is an exponential. So just by seeing that part, I know that I have that. But if you need to see more, I mean, we could always change it some more. And I'll do my Windows settings again. And I will change that to maybe, I don't know, 30, something like that. And then you can kind of see that it goes better like that. So what that tells me is that it is concave up. And if it is concave up, my rates of change are increasing. So, hang on. Okay, sorry. All right, so where was I? The rates of change are increasing because it's concave up. So if they're increasing, then the rates of change from 9 on, let's say that that's 9. That looks like a 7. Okay, that's why I wasn't going to write it. Let's say that that is 9 and this is 6. So from 6 to 9 and then 9 on, the rates of change from 9 on are greater because this is it is concave up. So then I'm just going to kind of I'm going to type again. Well, yeah, well, maybe I'm going to try to type. I still don't know what was wrong with the other one, why it wouldn't type for me. So let's type here. What I would say here is this. I would say that the average rates of change. See, I don't know what's happening, what it thinks I'm doing. You might have to deal with my handwriting. Average rates of change from, of S from, yeah, now I gotta make this thing bigger. All right, let me type this out because it may take me a while, and then I'll come back and then we'll talk about what I'm trying. All right, so here's what I wrote. Average rates of change of S, average rates of change of S from t equals 9 to t equals p weeks, so I'm just getting that straight from the question, are greater, because we decided they're increasing, than the average rates of change of S from t equals 6 to t equals 9, because S is always concave up. Oh, I should have added something else, and now I'm going to have to write more text. Just let me pause again. Okay, I said because S is always concave up, therefore average rates of change of S are increasing. So I did need to say that they were increasing, and that's how I knew. And remember those little 3 dots there, that means because. I'm not, oh my God, no it doesn't. It means therefore. All right, so then it says, Mr. Passwater plans to shovel snow until there is no snow left remaining on his driveway. Explain how this information can be used to determine the domain limitations for the model S. Well, I was having a hard time figuring out what exactly to say here, and when I read what was on the thing, to me it's not an explanation, so I'm not exactly sure what they want from you here, but I can tell you that this, this was a question, they asked you this like with the ice cream cone question, and it was actually asking you for range, so you're looking for a maximum. Here, what I think they're trying to get you to say, although I don't know how it really helps you with the domain. Let me read what they have. They have Mr. Passwater's plan to shovel snow until there is no snow left remaining on his driveway, that there is a value of t when he will stop, or S of t equals 0. S of t is a decreasing exponential function and will therefore get arbitrarily close to 0. I guess, let me go back up and read the question here. I guess it actually did say that. Began shoveling. Okay, so it doesn't really say that that was his plan. So if his plan is to shovel until there is no more snow, well, this model doesn't really make any sense because technically we never equal 0. I think that's what they're trying to get to here, is that you will, since it's exponential like this, you will approach 0, but you won't actually get to 0. So, I mean, that's something that you could say there, but I am not going to try and type or write any more on this question because it makes me want to scream. All right, so now we're going to go on to 3. And I think y'all are getting better at this. So you have to go into it with positive thinking here, all right? I know you don't like it, but you got this. Spend some time figuring this out before you start trying to come up with any numbers anywhere. And remember, by this time you are tired, and this is a lot of words. So a miniature golf course includes one hole that requires players to hit the ball through an opening in a large structure in the windmill. It rotates in front of the opening. The figure shows a windmill rotating in a clockwise direction that completes one rotation every 20 seconds. Okay, so let's talk about this for just a second. I'm going to go back to over here. All right. So this says one rotation. Oh my God. One rotation for every, I already forgot, 20 seconds. 20 seconds. All right. Now, yesterday we had one that came up on Jeopardy. I don't know if it came up in every class or not, but it said something like, something had 50 rotations. Okay, pretend like you can read that. For 50 rotations per second, okay? And for either one of these, we have to come up with a period for this. So this means I have 50 rotations for every 1 second, right? So one of these we're kind of good with, and the other one we got to figure stuff out. Remember, one rotation, it would be like starting here on the unit circle and going all the way around, like going from 0 to 2 pi, pretend like that's a circle. Or this would be like one rotation. It's one cycle. So one rotation, one cycle is one period. So here, where I have this as one rotation is 20 seconds. That means this is my period. The period is 20 seconds. Here, I don't have one rotation, I have 50. So set up a little proportion. Y'all are rock stars at proportions. So I can say I want to know one rotation. How many seconds is that? Because what happens is you try and reason through this, and then it's very easy to reason backwards and then just confuse yourself and then get frustrated. So we're going to cross multiply and we're going to get 50. Oh my gosh. 50x equals 1 times 1 is 1. Let me also say you only cross multiply across equal signs. If I did 1/2 times 3/4, we are not cross multiplying. You multiply straight across. So be careful. And then that means then I divide. So I get x equals 1 over 50. That would be my seconds. That right there is the period. So for this one, the period is 1 over 50. For this one, the period is 20. So that's how you can organize your thoughts to help you with that. All right. So in that case here, if I have one rotation for every 20 seconds, again, that is my period. All right. Point B is on the tip of one of the blades. Point X, which does not move, so X is right there, it represents the top of the opening of the structure. As the windmill blade rotates at a constant speed, the height of B above X, so here's where X is, this is the height above that we want, periodically increases and decreases. At time t equals 0, B is at its lowest point. So B would be right here at t equals 0. 2 feet directly below X, okay, and it shows me that. At its highest position would be right here, and that's 10 feet above X. The sinusoidal function h models the height of B above X in feet as a function of time. A positive, here's important, a positive value of h of x indicates it's above x. A negative value indicates below x. Now, I will say on the picture, they were kind of nice. Not only did they tell you that, but they actually have that right there. So that means we know we have an ordered pair of 0, -2. -2. Right? That's where we're starting. And then I know also if I go, it takes me 20 seconds to go all the way around. So I'm going to have another ordered pair of 0, no, that would make no sense, of 20, -2, right? Because I'm here, takes me 20 seconds to get all the way around, so I'm back there at -2. All right, so, and if I halfway between here, that is 10 seconds, and then I'm at my highest point, which is 10 feet above x, so I have 10, 10. Then this is what I want you to do on these graphs. You're going to start with just your y values, because I think that is the easiest thing for y'all, and we can get ourselves a point here. So we're going to go down here. Now, I'll remind you once again, you will have a lot more room to write on the actual exam, and the little ordered pairs should already be set up for you. But I'm going to cram my stuff in here, and this is, I know this is going to look like a hot mess. I wish I had other alternatives. Okay. All right. So I know that when I'm at the lowest position, my y value is -2. And when I'm at the highest position, my y value is 10. I need to get my y value for the halfway point. Now, there's two different ways to go about this. You can actually find the amplitude and then do that, or you can just average these points and you can find the actual position. That's probably the way I should have explained it this morning. But so if I add these two, 10 plus a -2 is 8. Divide by 2 and I get 4. When you get these numbers in the middle, here's what you want to double check, is that whatever the distance is between 10 and 4 needs to be the same distance from 4 to -2. So from 10 to 4, that's 6 spaces. From 4 to -2, that's 6 spaces. We're good. Okay? There are my y values. I think I have the great majority of you on board with how an x or a y-axis works. We have to go least to greatest. Now, that, just getting your y values on there, that's 1 point. That's why we want to do them a piece at a time so we don't mess it all up if we get confused on something. Now, I know up here, because when I was writing it down and trying to make sense of things, I know that 0, -2 is a point. But this can't be 0, -2 because then this gives me negative time. So I need to extend my graph. And I am going to extend it to right here. We did another one where you had to extend it more. You can extend it to wherever you need to extend it to. But I'm going to extend it to right there because I just need to get down here. And I'm going to make this 0, -2. Okay? So that's 0, -2. So if I start here at 0, I have a 20-second period. I'm going to end there. This has to be 20. Oh my gosh. Hang on a second. I'm going to change my colors so we can look at these differently. All right, let me put the ordered pair here because I want you to see how these are different. So I know that this is -2. And then, all right, so this is 0. This is 20. Remember, everything is spaced evenly with these sinusoidal functions. So for my x values, halfway between 0 and 20 is 10. Halfway between 10 and 20, or I can, 10 plus 20 is 30, divide by 2, I get 15. Right? And then I can see that, like, if I got this one, this would be 5, right? So 0, 5, 10, 15, 20, so this would be 25, and this would be 30. And then I would get another point for my x values. Point for x, point for y. And you can cross your fingers and hope that they will give you whole numbers and not crazy stupid fractions. But if they give you crazy stupid fractions, don't make up math. Do the best you can. And even if you like get them on there and you're like, you know what, I know these are wrong. Here's what you want to make sure that happens. My pink numbers are my y values, least to greatest, this direction. My green numbers are my x values, least to greatest going in this direction. And so at least do that much so that when you try and use these in another question that you can, or another part of this, that you can actually maybe function with your numbers. Okay, so then for the B part, we want to, it can be written in this form. So it has to be cosine. I can't decide I want it to be sine because they straight up told me cosine. And so my cosine could start here. It could start here. It could start here. It's just got to start at a max or a min. If I start at a max right here, then I don't have, then A is going to be positive. Now, it's asking me to find the values of the constants. Don't actually write it in the form of an equation. If you do and everything is correct, then you're fine. But if you mess anything up in the equation, the whole thing is wrong. So they didn't ask you for it. Let's not do the extra stuff, okay? So I'm going to need an A, a B, a C, and a D. The way these points work is you get 1 for your vertical transformations and 1 for your horizontal transformations. So A is right here, okay? That is a vertical dilation. It's a vertical stretch or compression. Remind yourself of that because since it's vertical, it means you are looking at the y values. Because some of you were doing I think have the right idea and doing the right subtraction, but you were totally using the wrong points. A is my amplitude. It's this length right here or right here. So that is a y value. So 10 minus 4 is 6, or 4 minus -2 is 6. My amplitude is 6. So A, 6. And if I'm going to decide to start here, it's a positive 6. Then my other vertical transformation is the D part, where we shift up and down. Well, they put the midline in here. These two numbers should match. This number is your D, so that is 4. So if I can get A and D correct, that's 1 point. All right. Then I have to get B and C. Well, B is right here, and that is related to the period. So the period we already said was 20, so I take 2 pi divided by 20. That leaves me with pi over 10. And then C is my shift left or right. So here I look at my x value, because remember the B and C, these are for x. This is at 10. We know that the parent function of cosine starts on the y-axis, but I'm starting here at 10 instead. So if I'm looking at this part, that would be t minus 10, because we still know that x is a liar. We move to the right 10, so it's minus 10. So since it's set up like that, C is negative 10. Now, another option, like if you worked this and you got something different and you started here, then A would be a negative 6 and C would be 0. And that is an option. But not everybody's either comfortable with starting upside down or thinks to do it that way. 1, 1. Because remember, there's an infinite amount of equations I could write and get the exact same graph. So there we go. Now, and let's say that we couldn't get any of that. That was just a hot mess. Then but I still can get something. I can at least narrow this one down. Okay. I may not know if the function's positive or negative, but I will know if it's increasing or decreasing. So this tells me K to P, and these change a lot. So they're all the same ones. I think some of you assumed on the last one that we were using the same piece of the graph, but here's K to P. I would say that is definitely increasing because my Y values are getting bigger. Nobody's asking me about slope here or rate of change. So Y values are increasing. So the function is increasing. That eliminates B and D. Now I got a 50-50 shot if I've messed my numbers up or don't know what's going on with the rest of it. At least I've narrowed it down. But I had some negative numbers down here, but from 4 to 10, because those are my Y values, that's all positive. So my answer is A. And remember on the answer sheet, all you have to write is A. That's all you have to write. That way you don't accidentally like copy the letters or copy the words down wrong. All right, so then rate of change. If you couldn't get anything else on this question, you can get this. Because we're talking about rate of change, so we want our fun chart. All right. I want my fun chart. And when I look from K to P, regardless if there could be nothing else on here. Maybe I should have started this question by like showing you just, hey, let's just do that one first. From K to P, the function is concave down. Since it is concave down, it is decreasing. Now, since the function's increasing, the rate of change is positive. But remember, they didn't ask me that. It just asks how it's changing. So I don't even care about that part right here. I only want this because I don't want you to get half of this wrong and then it matter because it may or may not matter. I think I'm going to try and write this out because even though my handwriting will look insane, it's better than, I don't know what's going on with this text thing. It doesn't like me. So I would say the rate of change of H is, all right, it's concave down, so it's decreasing. I'm checking myself again because I think this morning I said decreasing, wrote increasing, but rate of change of, that looks like his, but yeah, who's his? Okay, of H is decreasing on T1 to T2 because H, do not say it. H, the function, or you can say because the function, really should say H. The rate of change of H is decreasing on T1 to T2 because H is concave down. If this is the first video you've ever watched of me, you would never watch another one, is concave down on, you can either say on that interval or on just T1 to T2 to me is, I mean, it all sounds very repetitive. Your English teacher probably wouldn't like it, but that's what we're looking for here. Okay. No, change, whatever. They don't take off for spelling, so you're fine. All right. Oh, points. I lost points here. So there's a point here, and then you know where those other ones came from. Don't give up. Keep going. You can do this. You don't have to prove why you know this. So again, if you can just narrow it down to 2, then just pick one. And then from here, you should be able to get that. I think y'all got this fun chart down now. You didn't like it at first, I know, but you're going to be fine. Okay, my watch just told me it's time to stand because I've been sitting here for way longer than, what does this say, 54 minutes now? No, I've started over and dealt with text. Okay, here's 4, okay? We are going to rewrite as a single logarithm with base 10 without negative exponents. Okay, You promised me on the last mock none of us would miss this, and some of y'all broke my heart. Don't break my heart again. So before I do anything, this 1/2 becomes an exponent, and the 3 becomes an exponent. I only have two terms here. So this is log base 10, so g of x equals log base 10. And even though if you leave off the 10, it's still a common log, since they put it there and they were nice, go ahead and put it there. So also so you don't do anything weird. This is subtraction, so it's going to be a fraction. In the numerator, I get x to the 1/2 power. And in the denominator, I get x to the 3rd. And I am done. Okay. Now I'm going to rewrite h of x as an expression in which cosine of x appears once and no other trigonometric functions are involved. Okay, so we have h of x equals, so I'm just going to rewrite this, sine of 2x over sine of x. All right, so sine of 2x is different than sine squared x, so I cannot cancel anything out here. That is a double angle. Now, if you have not watched the video where that I made last week, where I go over the identities and kind of how to get what you need to do that, okay? Because I'm going to kind of start in the middle of that, and I will show you what we can do here. But I think since I have to write bigger, I'm going to go back to this page. All right. So we can get there from a non-negotiable. Your non-negotiable, remember there's 2 trig identities that you absolutely have to know. One of them is sine. Jesus. Okay. Sorry, this is just pathetic. Sine of alpha plus beta. And this gives me sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. Okay, that's one of your sum identities. Now, if I want, what I want is sine of 2x. Sine of 2x. I'm writing too big, I can tell. Let me move over, I'm going to run out of room. Sine of 2x, which is the same as the sine of x plus x, because x plus x is 2x, right? So basically, I'm going to substitute x in for alpha and x in for beta. So this will give me the sine of x times the cosine of x plus the cosine of x times the sine of x. Right, so basically what I did is alpha is x, beta is x. I just substituted them all in. Now when I look at these two, sine times cosine is the same as cosine times sine. So sine of 2x is equal to 2 sine x cosine x. Right. That looks like 25, but that's an S for sine. So this is my double angle identity. If you just know it, that's great. Again, some of you may just know them. You're not going to be an expert at all these, and that's okay. But you should at least go through that video and copy it down a couple of times so at least you can recognize some things and you may be able to get there. You might surprise yourself. All right, so what that means then is I'm going to take, instead of sine of 2x, I'm going to replace it with 2 sine x cosine x, that I just realized is what that identity is, over sine x, and then these cancel out, and I get 2 cosine x. And I'm done. Now, what I have noticed about these, oh no, I don't know what the heck I just did, what I hit. I was trying to get help. Yeah, definitely need help. Is that, so this says rewrite as an expression, which is what I have. Sometimes it says rewrite as a fraction. So if it says as a fraction, then you might end up with something like that or whatever it is. So they're pretty specific, and that might kind of help you with like your end goal there. All right. let's look at BI. So we have j of x, and it says solve j of x equals square root of 10 for all values of x in the domain. All right, so 10 to the x times 10 cubed minus the square root of 10 equals the square root of 10. Now I'll say again, you are now on FRQ 4. You are so tired and ready for this test to be over. You've been doing math forever. Okay, so don't skip steps, because this is where really careless mistakes start to happen. These square roots of 10 do not cancel each other out. I see that kind of mistake all the time on even super simple things. So I would have to add the square root of 10 to the other side. So this is going to give me 10 to the x times 10 cubed equals 2 square roots of 10. All right, now I have 10 to powers on the left, and on the right I have the square root of 10. I can change that to a power. Plus, now when I'm multiplying these two, that means I add the exponents. So this is going to be 10 to the x plus 3 power equals 2 times 10 to the 1/2 power. Okay, so sometimes when we get, let me just do a little something over here. If I had like 5 to the x equals 5 to the 7th, then I can drop the 5s and x equals 7. Super simple. I do not get to drop the 10s here because I got this 2 here. And there's nowhere to divide it out or do anything else with it. So what I need instead is to get all my exponentials on one side. So to do that, I divide, because this is being multiplied. So I'm going to divide both sides by 10 to the 1/2 power. So this will give me 10 to the x plus 3 power over 10 to the 1/2 power, and that equals 2. I can't get a common base because 2 to any exponent that I know that I can calculate it that way, it's not going to give me 10, and same thing with 10. But I do know that since when I multiply these, I added the exponents, since I'm dividing, I'm going to subtract the exponents. And there's no need to, and this is a 1/2 is the exponent, because again, bad handwriting. I can, 1/2 is 0.5. This is a simple decimal. It's not a repeating decimal, nothing like that. So 3, when I subtract, I get x plus 3 minus 1/2. Really, 3 minus 1/2 is just 2.5. So this is going to give me 10 to the x plus 2.5 power equals 2. That looks like a 7, but now 2.5. Just, you're going to have to bear with me. I think I'm losing it completely now. All right, so the way that I get, I still can't just like drop anything because they don't match. The way that I get variables out of the exponent is with logs. So let me remind you of something else here. That log base, maybe I can get it up here. Log base 5 of 5 is equal to 1. Natural log of e is equal to 1, because when the bases match, so log base, I don't know, star of a star equals 1. It doesn't matter what it is. So what I can do here is I'm going to have to take the log of both sides. I would really like the logs to kind of take care of themselves over here, so that that x plus 25 can come out in the front. So if I take the log, and that can just be a common log because that's base 10, log of 10 to the x plus 2.5 power equals the log of 2. Well, here, just like the natural log of e is 1, the log base 10 of 10, that is just 1. That leaves me with x plus 2.5 equals the log of 2. And then I subtract 2.5 from both sides. X is equal to log of 2 minus 2.5. And that's my answer. That's a 0.5. There you go. Okay. All right. Next part. I have k of x. So k of x is 2 cosine inverse of negative square root of 4x equals 5 pi thirds. There we go. All right, so I need to get x by itself, which means I need to get this cosine inverse away from it, which means I need to get this 2 away from it. So the first thing I'm allowed to do legally is divide by 2. So this is going to give me the cosine inverse of negative square root of 4x. And when I divide by 2, it is the same thing as multiplying by 1/2. So this gives me 5 pi sixths. All right. Now I need to get rid of the cosine inverse. The inverse of cosine inverse is cosine. So I'm going to take the cosine of both sides. Okay? So the cosine of the cosine inverse, they inverse each other out. And this gives me negative square root of 4x and equals cosine of 5 pi sixths. All right, so then negative square root of 4x is equal to negative square root of 3 over 2. Then I would, to get rid of the square root, I'm going to square both sides. Okay, when I square both sides, they become positive, or I could have knocked the negative out by now anyway, either way. And then I square this, I'm going to get 4x equals, well, the square root of 3 squared is 3, 2 squared is 4. Then I'm going to divide both sides by 4, and x, which is the same as, when I divide by 4, it's the same as multiplying by 1/4, so x equals 3 over 16. Whew. There we go. All right, now remember that part C on FRQ4 is always going to be difficult. That does not mean impossible, okay? I don't want you to leave it blank because you can at the very least set this up. And part C might be such a disaster overall, depending on what they put, that maybe, just maybe, you'd get one of the 2 points for this. Because remember here, let me go back up to the grading, you get 1 point here, 1 point here, 1 point here, 1 point here. You're going to get 2 points here. 1 point is kind of for a halfway point, and I'll see what, once we get there, I'm not sure if I know where. I'll have to find the answer key so I can tell you what the halfway point is. But so what this means is find all input values, which means give me all the x's that yield an output, which is your y, of 2, which means that m of x equals 2, which is the same thing that they've been saying on all of these. Look, solve j of x equals square root of 10. That is, for all the output values of the square root of 10. I mean, that's what it is. So, that's a nasty looking y, but that's what it's asking you. They're just using fancier words. Do you even understand what the words mean? I'm going to take this equation, which is 3 sine squared x plus cosine squared x minus sine of x equals 2. Bam. I set it up. Okay. So now I see some squareds, which tells me it's quadratic in some way. But really, in order for me to factor, because I can't factor out a GCF anywhere. And when I subtract that 2 over, I'd actually have 4 terms. I would like it all to be in sine, and I've got a cosine in there. Now, I do know that sine squared plus cosine squared is supposed to equal 1. However, this 3 sine squared, so it doesn't work that way. Okay, so can't really do that. I could split these and take care of some stuff, but I'm afraid that might make it even worse. Now, this one, I mean, it's doable and it's not crazy town or anything, but if you're like, you know what, I already have struggled with that, I don't want to make this any more confusing, I can understand not wanting to watch this part. But, I mean, heck, it's been entertaining up until now, right? Might as well watch it. So here's what we know, okay? Okay, I've got all that. Well, let me just clear that off. We know, here's another non-negotiable. Sine squared theta plus cosine squared theta equals 1. I would like to get rid of that cosine squared there. So I know that cosine squared theta is equal to 1 minus sine squared. So I'm going to put that in there. Instead of cosine squared, I'm going to get 1 minus sine squared. So let's go back over here. All right. So I have 3 sine squared theta, or sine squared x, I'm sorry, plus, now instead of cosine squared, I'm putting in 1 minus sine squared. And I'm putting it in parentheses because that is best practice to always do when you have more than one term. Minus sine of x equals 2. All right, now I put the parentheses in there, but in this case, they happen to not really matter, right? That's fine. But I have 3 sine squared x minus sine squared x is going to leave me with 2 sine squared x. And then minus sine x, because I got that, because I'm putting them in order. And then plus 1, and that equals 2. Remember, I have a quadratic, so I'd like to set it equal to 0. I could have set it equal to 0 before I did that. It doesn't matter. But I have 2 sine squared x minus sine of x. And then when I subtract 2, that'll be minus 1 equals 0. Now, I need to factor this. If the signs bother you, put hearts in their place and factor it. I have to factor by grouping here. Okay? I mean, there are other ways, but I think that that's what y'all do here. And so I get 2 times a negative 1, that's a negative 2. So I need 2 numbers that multiply to give me negative 2 and combine to give me negative 1. Well, that would be negative 2 and 1. So I'm going to split this, and I'm going to get 2 sine squared x minus 2 sine x plus sine x plus 1, no, not plus 1, minus 1 equals 0. Then I factor by grouping, right? Group that, group that. Out of these 2, I can factor out a 2 sine of x. That leaves me with sine of x minus 1. Here, I can factor out a 1, and that leaves me with sine of x minus 1 equals 0. Then I keep going because I'm not finished factoring. This gives me 2 sine of x plus 1 times sine of x, x minus 1 equals 0. Then I use my 0 product property. Set these equal to 0. And so I'm going to get 2 sine x equals negative 1. So sine of x is equal to negative 1/2. All right, so this says, let's see, what do I need to do? It says, in the domain of m. So like it's not telling me from 0 to 2 pi or whatever. So when it doesn't tell me that, I'm going to have to use plus by 2 pi k and things like that. But I still need to go, around 2 pi. So sine is negative here and here. So I need my 3rd and 4th quadrant angles here. Let's see, in the first quadrant, if sine is 1/2, that's pi 6. That means I need 7 pi 6 and 11 pi 6. All right, so then I'm going to do the same thing over here. Sine of x is equal to 1. Well, that's only here at pi halves, so x is equal to pi halves. Okay. Now, if this had said from 0 to 2 pi, there are my answers. Okay, but it didn't. It said in the entire domain. So I have to say x is equal to 7 pi 6 plus 2 pi n, 11 pi 6 plus 2 pi n, and pi halves plus 2 pi n. Those are my answers. Now let me look at the answer key here and see where they decided that the halfway point would be. So it's not really a halfway point here, but what the first point was these solutions without n. So if you didn't get them, if you didn't put the n's in there, then you still get a point. Okay, and actually it said 2 of them, so even if you only had 2 of the 3, you'd be good. And then you get the other point for basically having everything. But remember, please remember this. You are, yes, we want to shoot for perfection. We want to shoot for a 5. We want to shoot for a perfect score. But if you cannot work out a question, it is okay. Do not let it defeat you. Do not let it just make your brain shut down where you don't want to do anything else. You scratch and fight for every single point you can get, and I promise you, you can do this. All right? And that is one of the longest and worst looking videos I've ever made. So please let me know if you have any questions or, I think the math is right. I hope so anyway.